Hello again all. So this is my second video on Pythagoras and his theorem, which I've written out here and done a tiny sketch of, where A and B are the two shortest sides on a right angle triangle and C is the hypotenuse. A squared plus B squared equals C squared. Now we can find a simple missing side quite easily because it's just about plugging the numbers in. However, sometimes you can be given slightly harder questions, and that would include you doing a bit more problem solving. So I'm going to give you a few examples. First one here is, there is a triangle with side lengths 5, 9 and 12 centimeters. Is it a right angle triangle? Now, if I sketch that out, it will look like this. I've got 5 centimeters, 9 centimeters and 12 centimeters. How would I prove whether or not that is a right angle triangle? Well, if it's a right angle triangle, then 5 squared plus 9 squared would have to equal 12 squared, because A squared plus B squared equals C squared. Now let's try it. 5 squared is 25. 9 squared is 81. What is 25 plus 81? For those of you who want the calculator, 25 plus 81 equals 106. Is 106 12 squared? No. So it is not a right angled triangle. So it's just about using what you know to be true. As in, you know that 5 squared is 25. You know that 9 squared is 81. You know that 12 squared is not 106. So that cannot be a right angled triangle. I'm just going to pause for a second and get the next question up. My second question says, a wooden frame is made out of 4 pieces of wood. Let's say rectangular. A rectangular wooden frame is made out of 4 pieces of wood, 2 of which are 4 meters long. A beam supports the frame through its diagonal. If the beam is 5 meters long, as in the beam that's through the diagonal, what is the height of the frame? Now, if I sketch that out, it looks like this. I'm just going to get my pen and add in the information we know. We know that this here is 4 centimeters. And we know that this here is meters. 4 meters and 5 meters. That means we are trying to find this missing height here. Now, if I look at that, and even if I just think about it, we know that a rectangle can be broken into 2 right-angled triangles. So if I draw my little right angle in, I now know that I've got a triangle that would look like this. A right angle, 4 meters, 5 meters. Now that looks like something we can deal with our Pythagorean theorem. Sorry, difficult for me to say. Now that means we're looking for this side. We can't do it in its normal format because we're not looking for the hypotenuse. We're looking for a shorter side. So we know that 5 squared equals 4 squared plus something squared. 25 equals 16 plus something squared. If I take away from both sides, solve this like a normal equation, that means 9 equals something squared. We all know what the square root of 9 is. So that something is going to be 3. So that means I know that that missing side there is going to be 3 meters high. Again, as much as it looks like it's much harder, it is just the same theorem that we have been using before. It's going to give you one more example. Now, this example is probably the hardest one you'll get. An isosceles triangle has a base of 14 centimeters. The 2 slanted sides are 25 centimeters each. What is the height of the triangle? Now, I've sketched that out. I've got 14 centimeters along the base, 25 centimeters on each side. Now, I know that because I'm using Pythagoras, I need to find a right angle triangle in there. But how am I going to find it? Well, I'm looking for the height. So I'm looking from the top of here all the way down to the bottom of there. That is my height. Now that I've split it, if I was to just turn it ever so slightly or put this in, I can now suddenly see that I've got 2 right angled triangles. If I was to sketch that out, I'm just going to sketch out one side. I've got one with 25 centimetres there, an unknown h, what I'm looking for, and what would be along the bottom? Well, it would be 7, because I split it directly in the middle. Because it is an isosceles triangle, when you find from tip to base, it's always going to be halfway through. So now I've got another right angle triangle that I can find just as normal. This is my height. This is my slanted height. That's my other one. This is my hypotenuse because it is opposite the right angle. And now I can solve as usual. So 25 squared equals 7 squared plus something squared. If I'm going to use my calculator for that one, I'm actually going to rearrange it. So it's 25 squared minus 7 squared equals something squared. Put that into my calculator. I'll do 25 squared minus 7 squared equals 576. And then I square root my answer. 24. So this height is going to be 24 centimetres. So the height of my total isosceles triangle is going to be 24 centimetres. Okay, so that is the third and final example that I'm giving you. If you want to explore some more, some parts of Pythagoras that can be found interesting is Pythagorean triples. Now, I'm going to leave you to explore that. I might come back to it another time. But hopefully, this should get you through what I've set you for this week. Good luck, and remember you can email me if you do have any questions.